Thank you very much for the introduction. It's very nice to be here at this still intimate meeting, but I'm sure in the next few years this is going to be a much larger. So this is about the passion project, really one, I think a passion of several of us. I'm just the guy presenting here, but there are several people also in the audience who are working very intensely on this. So we wanted to address a very simple question that I think everybody is aware of, but still, let's go into this. I have a few conflicts of interest. I work with lots of companies, but none of these pertain to this talk, and also none of the money goes to myself, but just to my department. So you're all aware that there's many common skin diseases in Africa that remain untreated, especially in children. Check out the prevalence of these different conditions. I made a bit of an average. So atopic eczema, 14%, impetigo, almost 20%. Ringworm varies according to region, up to 80%, especially in the scalp. Scabies, 5 to 10%. Is it not a crime to leave these people, these children, untreated just because there's too little competence? And insect bites, probably 100%. We just put this in as a kind of positive control for this study, as you'll see. So in Africa, there's many children that suffer from a skin disease, and at the same time, there is really a bit of an inability to recognize them because there's low dermatologist density. So if you take, for example, Madagascar, Guinea, and Tanzania, you got one dermatologist for 1 to 2 million people. And even though there's really good initiatives to address that, for example, the Regional Dermatology Training Center in Tanzania and so on, it seems that this doesn't help too much, okay? Also because once one is a dermatologist, perhaps there's also a tendency to go to another country where you can earn more. Okay, so there must be other ways to kind of address this problem. Also, especially important, there's a high load of pediatric dermatology patients. You're aware that the population is younger anyhow than with us, and so there's 45% of dermatology patients actually under the age of 15 years. Okay, and so the patients and their parents, they are in a passive role. They are dependent on the primary care provider. In Tanzania, where I was for a year, for example, it's a medical health officer. Okay, unfortunately, these medical officers, they're also not dermatology trained. So they are also kind of dependent on outside help. Okay, and then of course lab diagnostics are scarce, and sometimes the location where people live is really remote. So many patients do not get the right diagnosis or good treatment. So the project is to empower patients and medical officers to diagnose correctly and then get the right treatment to the affected patients. And as you've seen in these conditions, it's not that these treatments are especially difficult. You don't need biologics to treat impetigo or ringworm. It's really a matter of just selecting the right drug. And typically also these drugs are available even in the poorest countries. And so it's of course obvious to say, okay, let's do teledermatology. I mean, come on, we are with the Teledermatology Society here. Okay, so we all have expertise, don't we? And then the next question is, well, do people even have smartphone connection? Okay, but at least in Tanzania, when people need a light in the dark, they will often use their smartphone. There is a large percentage of the population that has smartphone coverage. And as you can see here on the map, where you have population, you do have smartphone connection because that is kind of economically important, okay? You can make a lot of money even in these regions where there are few people, just because people want to communicate, okay? So this is really a device that people have. So basically, how does the dermatology work? I don't need to explain that to you. You all know, okay? So first, care providers would take pictures and file cases, or even the parents, if they're able to. And then initially in the countries where we try to to see whether our typical teledermatology appliance works, okay? Because we have a Derma2Go system, it's kind of a startup that it works very well in Switzerland, okay? You can upload pictures on a website and so on. We've tried that in Madagascar, which is one of the countries where we will run the Passion Project, and so it didn't really work so well. So the website was quite heavy to load, so we're actually now going back to something more simple. And what does everybody have? Huh? Of course, they have WhatsApp. It's really true. Also, it's free, and in WhatsApp you can actually use chat forms, and these are also secure. You're aware that WhatsApp actually has very high security, at least compared to other possibilities. So that's what we're going to use. Then the pictures are uploaded to a dermatologist, like with traditional teledermatology, and then you get feedback with a prescription. Okay, so far that's fine. That's not really a study, basically. Okay, well, we could establish teledermatology in Africa, fine, but it's clear that this is probably going to work. So the more interesting part is now, if you want to offer this for free for thousands of people, because of course, you know, the demand is amazingly high. If you check these numbers, of course, you'd like to have a validated AI that classifies the diagnosis and also prescribes. That's quite dramatic and shocking. How would you trust that? Well, perhaps it works. So we just have to validate. And that's what the Passion study is about. It's about, you know, making such an AI and then validating it compared to physicians. And so that's what we're trying to do. So we want to have a classification algorithm to detect diagnoses on submitted photos. And we've already established that with psoriasis and eczema already. For frequent conditions, you have sufficient numbers of photos, so you can really train an AI. The only problem is, guys, that if we use pictures, and we have almost 1 million now, we use pictures of pigment-poor persons, as we call them now, it doesn't work. So we need pigment-rich pictures, okay? And that was the first phase, and still is the first phase of the Passion Project, to collect sufficient numbers of dark-skinned pictures to make the machine learning algorithms actually work. And for anyone who is interested, we're using EfficientNet, several different versions to distinguish between these 5 initially different skin conditions. And of course, we've talked with Jose that we would even expand this to neglected tropical skin diseases, of which there are quite a few. But of course, there we also need pictures. So basically, we need new pictures. And in the last few years, we've now collected 4,000 images of 1,400 pigment-rich cases. That's, you know, compared to our 1 million, that's not so much. But still, it's the largest database that exists to our knowledge, and we have declared from the beginning that we will make this open source. So this will be free to everybody in an anonymized way. That's our goal. So who has, you know, collected lots of pictures? Well, our collaborators in Madagascar, they're really the strongest. So they have collected almost half of all pictures, and then collaborators in Guinea, Tanzania, and Indonesia have collected many pictures as well. And how are the diagnoses divided? Well, you see that there's quite a few scabies pictures, atopic eczema, insect bites, few, fungal infection, lots, and impetigo, very few. What Fitzpatrick skin types do we have? Well, we have from 3 to 6, so that's basically what we would expect and hope. We need pictures of pigment-rich skin, otherwise it's totally pointless to do that. And we've also thought, because with machine learning, you may be aware you have these augmentation techniques. So basically, we could augment our data set by just saying, okay, why don't we use techniques called diffusion models or generative adversarial networks to try to take our hundred thousands of pictures and, you know, transform them into dark-skinned pictures. And in a few experiments, this works very well. This is actually something by NVIDIA, so that this wasn't done by us, these faces, but it's amazing, right? But I can tell you, unfortunately, it doesn't work so well for us for training. But at least we've tried, okay? So far, it's really, it's quite pedestrian. we're just collecting pictures. That's the bottom line so far. And as Peter has pointed out, yes, this is a lot of work, especially annotation. But with collaboration and perhaps with WHO help and so on, and of course the Botnar Foundation, who is, financing our study, I think we're going to get there. We have with a few diagnoses already. So we are developing these machine learning models that are supposed to take a picture and make a diagnosis, of the 5 that we have, which is much easier than if you try to make a diagnosis of 200 different diagnoses, of course. For eczema, for example, in the European data set, you can see that we have 93% precision and 91% sensitivity, so that's kind of okay. And with the few dark skin pictures, we have 80% precision, 85% sensitivity. So it's also not so bad. And we said we will do the trial to validate this as soon as we have 80% precision in 4 of the 5 conditions. Also, we've found that we are not alone with this interest. So there's several companies who think, hey, I can be in Africa, I can offer these machine learning models, and I want to validate my machine learning model with this trial. So they are actually going to also provide their machine learning models, and we can then see which one is the best. It doesn't have to be our own. It's totally fine for me if it's a company's, as long as the company then offers this for free, that we can do this study. Okay. Also, federated learning, that may be something that you're aware of. Federated learning means that pictures do not have to be sent to a central database. So we don't want to be the European group that, takes all the pictures from Africa and keeps them in our vault in Switzerland. No, these pictures can actually stay in the country, in the Amazon Healthcare Cloud. And then basically we can just take these pictures momentarily for training. And this way everybody can have a machine learning model without actually having to share. And that means if you are in a position that you also have a large database of pictures, especially pigment-rich skin images, you can do the same thing. You can get a co-authorship on the study, and you can help us moving this project forward. So if you have that, please contact us, because it's a good thing. It's totally safe, and we're doing this on the highest standard. So it doesn't need anything on the lowest level here. The node without on-premise data and computational power doesn't need anything for this collaboration except your pictures, which have to be annotated, of course, with the right diagnosis. Otherwise, it doesn't make sense. But I guess that's kind of clear. So what's the timeline? We've started in 2020. Now we have the data collection going on, and we're doing the validation trial in 24. We will compare in-person consultations first versus teledermatology, so basically making photos in the waiting room, and then having a teledermatologist who is not the same person as the in-person dermatologist doing the teledermatology consultation, and compare that with the result of the machine learning models. And once that works very well, then we will go to actual remote situation. And I'll spare you the further details. So basically, telederm.ai for more information. Thanks for everybody who has contributed a lot, and looking forward to our dinner on Thursday. And of course, thank you for the invitation.
Thank you very much. That was very interesting. Do we have any burning questions? Because we're already out of time. Yeah? Mino. Are we having a microphone, please? No, it's for the recording, please, Mino.
Looking at the diagnosis, looks like you need insect bites and impetigo.
Yeah, especially impetigo. The insect bites, we've really put this in as a kind of positive control, because we assumed everybody would have that. And in a study, you need something like that. So especially impetigo, yes, that would be great. Yeah.
And I feel like that would be easy to collect everywhere in the U.S.
There,
and
you
other
would
parts
expect,
of
right? But that's
the
science,
world.
So yeah, and perhaps people do not make photos of impetigo so often. So just, you know, it should be trivial. So if anybody wants to help, please do that.
Thank you for clarifying.